Hi everyone, this is Ron Crider. Back in 1985, I was president of Lodestar Tower of North Palm Beach, Florida, and we built this site here that you're seeing. This is the almost finished version of the Lodestar Jacksonville tower site, and I'm going to tell you throughout this video exactly what was going on here. As you can see here as we begin, this is the initial layout of the tower site in Jacksonville off of Hogan Road, and we've, during the process of designing this project and building it, I filmed some of this video. In fact, I filmed most all of the video. We built the tower in conjunction with LeBlanc and Dick, a Canadian tower manufacturer, by the way, an exceptional tower manufacturer. We had gotten bids from Stainless here in the United States and Klein, who were the two big tower builders at that time, and LeBlanc wanted to build towers in the United States. They had already built one, and thereafter they built a number of towers for us. Here you can see they're beginning to put in all of the electrical work. Bob Dominics of Dominics Electric in Miami was overseeing the installation, and he was the contractor for the electrical installation here at the Jacksonville tower site. He was also our electrical man for our Candelabra Tower in Hollywood, Florida. He did Jacksonville. He also did the Orlando tower site. I think he did the Palm Beach and St. Petersburg tower site, along with the top of the Westin Hotel, I believe, in Atlanta, which is where we had some work going on. He was really good at what he did. And although he didn't know a whole lot about broadcasting when he first started with us, over a period of time, he really caught on and really understood what was necessary for the various generators and the primary power that had to get into the building, and the straps that we had, the copper straps that we had to put down for grounding and so forth. And it was great to be able to work with somebody on all of these projects who totally understood what we needed to do and would remember in case we forgot something how to do it. Larry Penner at LeBlanc and Dick up in Oakville, Ontario, was the primary designer of this tower. And bottom line, there's Bob Dominics right there. And as we started putting this project together, along with the people from Metroplex Communications, who owned the radio station there at this particular site in Jacksonville, they were actually our inspiration to put this tower up. We believed that we were going to be able to get 5 or 6 stations on this tower in the early stages of the construction of the tower, and so it was going to be a 10-foot face tower with an elevator. And halfway through the project, before we started the actual fabrication of the tower, I lost 2 tenants to another TV tower that was being decommissioned as a TV tower. In fact, this is the tower you're looking at here, is the existing tower that was on the site on Hogan Road. It was a 500-foot tower. This tower was here before we started building the 1,049-foot tower. So I chickened out and cut the tower back to an 8-foot face tower, no elevator, because I was concerned predominantly about the... by the way, if you look in the back, you'll see a big candelabra back there in the back, a TV station built. That was a big Klein candelabra tower. Really, really nice job. But I chickened out and cut the tower back because I had to try to keep in budget and make sure that the thing was going to be financially successful. And actually, it turned out to be a bad idea, because no sooner was the tower finished or almost finished construction, we had more tenants than we could put on the tower, and obviously that was a bad call on my part. Of course, if I'd gone the other way, the thing was a financial bust, then I would have been in really big trouble. So a lot of conduit, as you can see here, going in, and a lot of design work in the electrical design, electrical drawings to put this conduit in so that the pipes are going from the combiner room to the transmitter rooms, and the transmitter rooms to the base of the tower, and all the various associated power that's necessary, not for just the radio stations, which in this particular case there were 3 FM stations involved, with this tower project all going into one antenna. But there was also a communications room which was designed for cellular communications, and at that time paging was a big deal, and so there were paging companies and two-way communications companies and so forth. So there was an extensive amount of power and power distribution that was being set up here by Bob Dominics.
You're kidding, it'll never fit.
Then, in addition to that, we put a 250 kW generator in, and so each of the radio stations had their own power transfer switches so that anyone could go on the generator at any time if they needed to, or if there was a major power failure, then of course they would all switch to the 250,000 watt backup generator. And it was a big ONAN, it worked very well, and that was again part of the electrical scheme for this entire project here. And as you can see, these guys are busy trying to figure out what goes where. And as I said, this particular job was Dominic's third major tower for us. So he was beginning to feel like he really was an old salt at putting these things in. The gentleman that we hired and who ultimately went on our payroll as a general contractor, his name was William Lambert. And Bill, there you see him, he's on the left-hand side there. He built several of our sites for us as well and was very good at getting the building permits done. Well, that was a big problem that I had to deal with early on, was to get the building permits. It wasn't as difficult as many places would be, primarily because there were a number of other tall towers out here on Hogan Road in Jacksonville. So this tower was not very far away, I would say 1,000 feet away from another 1,049-foot tower, so one more tower wouldn't make that much difference. Of course, they had a lot of hearings, and lots of people were complaining about more towers and not wanting the towers there, but at the end of the day, yes, we did get permission to build it. I also have to say that 8 months after the tower was completed, I got a call from the FAA who informed me that the tower was 49 feet too tall and we had to take 49 feet off the top of the tower. Well, we never planned on it to be 49 feet taller than it was supposed to be. It was never designed to be that way. We weren't trying to pull the wool over anyone's eyes, but it was a major embarrassment because someone had failed to take into consideration that this tower is not at sea level. It was 49 feet above sea level. And so therefore, in order to be 1,049 feet in the air, we would have had to have made it 1,000 feet. Unfortunately, the top 49 feet was also where the cantilevered FM antenna was located, so it wasn't going to be very easy to chop off the top of the tower. So at the end of the day, after a lot of problems with the FAA, we were able to prevail upon them to let us maintain the height, which was then 1,099 feet and a little under 1,100 feet. And we were not allowed to have any bragging rights or anything. They didn't want us to do that, fearful that that was the plan in the first place, which it absolutely was not. And it was some expense involved, additional expense for us, because stations had to refile a lot of their engineering data with the FCC in order to make that difference take place. Here you see the building is beginning to go up. It's a good, strong concrete block building, and designed by myself and a couple of my associates, along with the station engineers from the various stations that were going to use this facility. And it was a joint effort with all of us, but our company, Lodestar, was primarily responsible. My partner in the deal, Paul Lansett, was in charge of all the finances, and he was the man who put the money together and arranged for the bank loans. This particular tower, if I'm not mistaken, was then financed by Ameritrust in Cleveland, Ohio. Chesley Maddox was our lending officer at the bank at that time, and we were very fortunate because this was a good time to get into the tower business, because the FCC had changed the rules and said that if you were under 984 feet, you were going to be downgraded. If you were a Class C station, you would be downgraded to a C1, C2, depending on how high you were, which would then limit your power and limit the protection that you had. And at that time, these stations were going for a great deal of money. Banks had loaned a great deal of money out on these stations, and needless to say, the last thing the bank wanted was their stations to be downgraded. So therefore, there was a real need for these towers, and the bank was willing to back the broadcasters in the venture with us. Now, although we owned the tower, and they leased from us, there you see Paul Lancet in the middle standing there, and William Lambert on the left. This was May 1st of 1986, and Paul was there. Reason we were all here at that particular day on May the 1st, or May Day, so to speak, was because this was our official so-called groundbreaking, and we had a bunch of people from the office come there, and some of the people from the other radio stations came there, and we did a little media event. Here you'll see the results of what happened after they put in their all the conduit for the electrical wiring. I can't tell you exactly where this is, but it does look it could possibly be in the generator room, if I'm not mistaken. And then, of course, a lot of these pipes had to pop up in the combiner room to get the power over to the combiner, and then into the room for the various communications companies that had space there as well. We also had restrooms at this site, which a lot of tower sites at that time did not have restrooms. I don't know who these guys are here. They may have been from the bank. They certainly look very official and look very much like bank guys. We did a tower in New Orleans, the biggest tower we built, the most expensive tower we built, not the tallest. The most expensive tower we built was in New Orleans. It was 1,049 feet. One of the few towers that survived Katrina. Foundations for that tower in 1986 cost $500,000. The bankers came in after the tower was finished, and I asked them if they wanted to go for a ride.
Who's it from?
There's a double car elevator on that tower. I took them for a ride. I got them up to the first level on the tower, and that was about as far as they wanted to go. So, but at least they could go back and tell their home office that they had really inspected the property, and yes, in fact, there was a real honest-to-goodness tower there. Jacksonville went off pretty much without a hitch. As you can imagine, it's a pretty complex deal to design a transmitter building. Also to design the tower itself and get the foundations put in. It wasn't a 80% guy radius tower because we didn't have a lot of property space. The only little hitch we ran into, other than the fact we built it too tall, was one of the guy anchors was off by, I think, about 11 or 12 inches. And that created a bit of a problem, but for Larry Penner, he came up with a workaround and got it totally resolved. That cost us a week or two, or maybe 3. Here you see the building is beginning to get framed out with the doors in it. We get along here a little further, you'll see the guy anchor points, and here is the...
This thing right here is the base for the foundation at the center of the tower.
That's me on site.
This thing over here
in 86
is the foundation, center foundation pier.
In case you didn't hear that, that's the center foundation of the tower, the base where the base will sit. And that's Paul Lancet over there inside.
Over here are the 3. Where Paul is standing as one of the foundation piers.
When do you expect to top this one out, Ron?
I'm gonna get that in just a minute.
So as you can see, Paul was about 5'6", 5'7", so it's about an 8-foot cylinder for the foundations. Coastal caissons put the foundations in for us at most of our tower sites in Florida. And as you know, when you dig a hole in the ground here in Florida, you go down about couple of feet, and the first thing you run into is a well. So it's not that easy, and there's not a tremendous amount of holding power in the soil here in Florida when you put towers in. So it takes a fair amount of concrete. There are the rebar for the piers. This man's name is Cal, and he was another one of...
We're all over here, Cal.
...the people that we worked with in Jacksonville. It looks like he's bringing us a new set of plans for the project. That's William Lambert. He's going to hand those plans over to William. And I don't remember exactly what Cal's position was with us. I know he only worked on this particular tower. This video is about an hour and 15 minutes, and you may find that it gets a little boring for a while, and you can kind of fast forward. That's one of the good things that you can do with digital. It makes it very easy to flip through it and take a look at it. The next scenes that are coming up will be that of putting in the actual center foundation for the base of the tower, and we'll be getting there in just a minute or two. That's, again, the framing out of the building behind us there.
Get you there, Ron.
There you see, I'm standing there somewhere. It's Paul Lancet in the middle, and pretty soon you'll see the rest of the people that were involved with this project, and there I am coming in there. That would be me. And this was a photo op for the newspaper and for a little of the promotion we have. But Paul and I have our foot on the shovel right there in the middle, and then all of a sudden a bunch of other people that were involved, Bill Lambert and some of the other people who were involved with us, were in on this photo op that we used to help promote the tower, because of course we were trying to fill, our job was to try to get as many tenants as possible on the tower. Our company was one of the early companies in the tower business that built towers for lease. We owned it, we leased them to the broadcasters. And the broadcasters, these towers were very expensive, so it was relatively difficult for a broadcaster to actually build one of these towers by himself. And in addition to that, getting the approvals were difficult, so by having a tower that we were sharing the space on was easier to get approved. I recall in the Orlando tower, which was a 1,749-foot tower, Volusia County said when they approved it, we're going to be sure that we're not going to issue any more building permits until your tower is full. And they were addressing that to us like we were going to come back and ask to get a permit to build another tower. And what they were really saying to me was, that sounds good to me, because that means we're not going to have any competition for a while. And it worked out that way. That tower got filled up pretty quickly. That was known as the Lodestar Orange City Tower, and that was a move-in tower for the stations in Daytona Beach. So a number of stations in Daytona Beach moved there, and then we ended up with a bunch of TV stations as well. We had a couple of television stations on it. So it was TV and a combiner for, I believe, 4 FM stations. And Orange City is located about 25-30 miles north of downtown Orlando. So it was a little bit further away, of course, than the Bithlo area, which is the common tower site for most of the radio stations in Orlando, but it did get the stations in there. Lady standing there on the center left is Renee Lancet, and she was Paul Lancet's wife, and she helped us with our bookkeeping and so forth. Here we go with the center foundation. As I recall, there was a lot of concrete went into this guy here, but this is where the base of the tower was going to be. And they started pouring a lot of concrete. Now I'm going to explain before we get in here too far. You're going to see one of the first things they do is they take some concrete from the concrete truck, put it into a wheelbarrow, and then they put that concrete into some cylinders. And every time they do a load of concrete, when they put the concrete in here, they do at least 3 or 4 concrete samples of the concrete that's in the concrete truck before it's poured into the ground. And then, as I recall, it was Jamal, if I'm not mistaken, a engineering firm that takes that concrete out and tests it to be sure that it has the appropriate holding power necessary to go into this foundation. I don't know enough to be able to tell you what the story is on that, but I can tell you that there's all sorts of tests that have to be done. And we also had to do that for our building permit to demonstrate to Jacksonville that we had put the appropriate amount of concrete in, and that the concrete that we did put in had the appropriate holding power. So each time a truck would come in to pour concrete in here, he would do sometimes 3 or 4 of these canisters of concrete. The first concrete that came off the truck would go into those canisters. We're going to get to that here in just a second. It'll go pretty quickly once we get over there to it. Now we're up to May 13th. As you can see, in 13 days, 13 days, we've made quite a bit of progress on the building. We had good weather at the time, and that was a good thing. Like I say, this project moved along very nicely. I was there a couple of days. Every week I was probably there 3, 4, 5 days for each week during the tower construction process, which was most of April and May and into June. That is where the primary power transformer was going to be placed to provide the power into the building. And as I recall, the building either had 1,200 or 1,500 amps of primary power into the building. And there was a transformer out there that, of course, supplied that power. There you'll see, right in the center, you'll see 3 little legs sticking up, 3 little nubs sticking up. That is the actual base of the tower. It's going to be mounted on the top of that concrete that you're seeing there a little bit earlier. Here we go, zooming in on it now. And this is where the actual tower is going to be built. Let's see. Problem with live radio here. Telephones are ringing in the background and nobody's here to answer them. So it's just going to ring for a few minutes and then it'll go to voicemail. Here is the one of the 3 pier foundations for the guide wires. They call them guy wires or guide wires. Guy wires are generally more accepted. And then a big giant fan gets attached to this, where all of the wires that go up to the tower, to each of the guy levels, are going to come into. This is the one that was off by about 11 inches. I took this shot to show that Coastal Caissons is the company that did most of our foundation work. And they did a really good job. They did Orlando, Jacksonville, North Palm Beach, tower we built over on the Gandhi Bridge in St. Petersburg. That was a 649-foot tower. That was a freestanding tower, and they did all of the foundation work for that tower as well. As you can see, they made a fair amount of progress here and got the doors in and got the door openings in and getting up the top where they're getting ready to put a roof on this building. This is the radio station that's the radio station that was at that site. This is the interior of the building, and once again, I probably overdid the video here, but just to give you an idea of the extensive amount of conduit work necessary for the radio station transmitters and audio equipment and so forth. And needless to say, it needs to be pretty well planned out in order to make it all work. And thanks to good old Bob Dominics, who really knew exactly how to do this, and he very seldom scratched his head because he could. The plans were well put together, and he and Bill Lambert and I don't know, Cal might have been the architect. I'm not positively sure, but they all worked together with us. I'm not sure if Doug Holland was in on this tower project or not. I know he came along when we did a 2,000-foot tower in Dallas, North Carolina. That's for a Charlotte TV station. It was Channel 36. That was the big, huge 2,000-foot LeBlanc and Dick tower. Fabulous tower. I don't have much video on that. You know, these videos are like your children. The first child you have, you take 2,000 pictures of your first child for the first 3 years they're on this earth, and the second child comes along and you take 200 pictures, and the third child comes along, you forget to take any pictures at all. Well, this was our second major tower project, and as you can see, I got pretty excited about videotaping, and these videotapes did come in handy over the years that we owned the tower and other people owned them, to see exactly where things were and get a pretty good idea of how it took place. So you can certainly fast forward here, because the next phase that's going to come up, they're going to pour the concrete in here, and you'll see in just a second what I was telling you about, how they do the concrete for the canisters to do the samples of the actual concrete and its holding capacity. Kind of a poor editing job there. I could have cut that out, I guess. Maybe I overdid the interior of the building a little too much as well. Sorry about that. Like I say, you can fast forward it. We're also doing videos at this time in Switzerland, and so you notice that there's pretty slow movement of the camera, which is what we were taught when we started doing Swiss videos, that it's a good idea to go very slow. Once again, another electrical trough in one of the transmitter rooms. Some of these guys, Bob Dominics brought with him from Miami to work on the project, and some of the people he picked up locally in Jacksonville at each one of the tower sites. He would bring a couple of guys with him, and then pick up some other local electricians to help put the project together. As I said, LeBlanc and Dick ended up being our partners in the tower business for a number of years, and in fact at the end ended up buying us out of the business and continuing to operate it themselves. Paul Dickey was the president of the company at that time. George Patton was the owner, president. I think he was chairman of the board. All of them came down here to oversee the project. Now, as I was mentioning to you here, they're going to fill this wheelbarrow up, or put concrete in the wheelbarrow, and then they'll take the concrete from the wheelbarrow and put it into canisters to be sent off for the actual testing. Those people standing back there, I took this just so that here we are in this was in 1985, and Now it's 2018, and some of these people might be interested in seeing themselves on TV. I think the guy on the left was the engineer for the Jacksonville station, and I think the fellow on the right there with the tie was the general manager of the Metroplex Jacksonville station. Oh, I threw this video in here just as a reminder. That was my nemesis tower that at the last minute got decommissioned as a TV tower, and a couple of our tenants defected from us to that tower and put their stations on top of that tower, and it was a really old tower. It was my position that we could have bought that tower, but it was my position that the maintenance on the tower and a very, very old tower probably was not a good business model. And so we did lose the tenants, but it didn't ultimately affect us because we ended up getting plenty of other tenants that we didn't anticipate, and of course cellular people came along. Okay, here we go. We're going to start dumping the concrete in here. I'm going to say that it was about 65 yards of concrete running here. I'm going to guess that that may be right, but I'm sure that you'll probably hear somebody say what it was. I know that there were a number of trucks that came here to unload this concrete. As I was saying, the LeBlanc and Dick people of Oakville, Ontario were very, very helpful, very professional in the design and fabrication of the towers, very easy to work with. I call myself a conceptual engineer. I designed the towers for the maximum amount of revenue that we could generate on them, and then I turned my conceptual design into Larry Penner at LeBlanc and Royal, and LeBlanc and Dick, LeBlanc and Royal, and they would then design a tower around what my needs were. Now, needless to say, I'm not a structural engineer, so I have no idea when I come up with a plan as to what it's going to take to make it happen. But even then, the computers were available to be able to they could input that data into the computers, and the computers would then design the leg size and so forth. Throughout the construction of the towers, I learned that the way we could figure out how competitive other tower manufacturers are, the first thing you want to find out is how big the legs are, because we specify those in our tower design. But Southern Concrete is obviously who we use for all of our concrete at this particular site. And once again, take the concrete out, and you can see it's a little hard to see there, but it's putting it in those black canisters back there. And I think each load of concrete goes into 3 different canisters. So there's 3 separate canisters for this concrete. And I don't know exactly why you need 3 to determine if it's going to work right or not, but that's the way it is. And every load of concrete had 3 of these canisters filled with concrete. So I was saying the people at LeBlanc and Royal, LeBlanc and Dick, they formed another company called Larcam with Jimmy Wilson, and Jimmy was a major part of helping us put things together. He was a sales guy, but a very nice gentleman, one of the nicest people I ever worked with, and he played a major role in the tower in North Carolina, the 2,000-foot tower. He did a lot of interface work with us and helped us get that deal put together. That was obviously there's the canisters, as you can see, all the different canisters from the various concrete pours. The North Carolina 2,000-foot tower was a huge undertaking because in addition to that, we built the building for the TV transmitter, and that transmitter was a 240,000-watt UHF TV transmitter. It was 460s, 4 60-kilowatt transmitters tied together. And to make matters even worse, the project got off slow. Oh, by the way, there's Crawdaddy's, in case you're interested in Jacksonville. I don't know if it's still there. That used to be a hangout for us at the end of the day to go over there and have a couple of beers. This is one of the radio stations, WIBY 103. It was one of the stations that was using our tower, and they were located close to Crawdaddy's. They're the ones who introduced us to Crawdaddy's, but Crawdaddy's had really good seafood. Okay, here we go. Now here is the base of the tower, and you saw that three-pronged system sitting over there a few minutes ago, and that's what's going to be mounted right there in the center of that base.
It's only about 95% done.
Good, good. It looks great. Give you any problems after I left yesterday?
No, sir, none at all.
Terrific.
Everything went real smooth. Real smooth.
Okay, we're going to pick up the audio and continue recording here. I took a little pause. Now they've leveled everything out, and there is the base of the tower. But these guys aren't going to drown me out too much. So the next event at this project was to install the tower base. And when they put the base in, they also put in the first, if I'm not mistaken, it could be the first 50 feet or first 100 feet of the tower that's all pre-assembled. It may be, I'm not exactly sure. You'll see it after it's in place here, that they pre-assemble it. Now, just to give you an idea as to how this tower goes together.
How many yards of concrete did you end up putting in here?
Here you go.
Slab or in this hole here.
In this hole here.
This one here's got 65 yards in it.
There you go, 65 yards. That was pretty close. So what's going to happen here is when they deliver the tower to the site, it comes in pieces. It's like a big adult erector set. The legs are separate. The diagonals are all separate. The tower sections are not delivered, put together like a Roan 25, 45, 55, those towers. These are all come in pieces on great big trucks. And there you see the base of the tower that is connected now to, this is the top base that's connected. There's one piece that goes in between here and the piece you just saw. Oh, no, it is. It's already connected. There it is. That's the square base, and that's the piece we were looking at before. And this is the first big section already put together. The crane is going to pick up and sit down on the top of that spot that they just poured that 65 yards of concrete in. And every one of these pieces, every one of those diagonals that you see in there are all put together at the site. So it takes about, as you can see now, we're up to June the 10th, and when last we left it was, I think, May the 13th. So in that period of time, you can count, these are the number of sections, 1, 2, 3, 4. So it might be 50 feet, 40 or 50 feet for this, if they're 10-foot sections. And there's kind of the jig that they use, and there are all the diagonals and all the pieces that they use to put this together. And of course they're all marked. You can see the one that back behind there, another section that's being put together. Then they lift that big section that you just saw into place and sit it on the foundation, and they attach the first set of temporary guide wires to that. And the next thing they'll do on that particular section, and they may have already done so before they actually, I think they did it, before they bring that base section up, they install a thing called a gin pole. And a gin pole is kind of like another smaller tower section that is strapped to the top of the base section that they're going to put in. And that sticks above the base section. It has a big giant pulley up there. And they keep moving that gin pole up the tower as they bring these sections up. I do believe those sections are 10-foot sections. So you'll see once they get the base put in, what I'm speaking of when I refer to the gin pole. Here they have the staging area for these sections ready to go, so they can just grab them and put them onto the crane. It's not a crane. Put them onto the pulley system that pulls it up through the gin pole on the top of the tower, and then they swing it around and put it into place. And keep watching. You'll notice as we get down here a little bit further, you'll actually see them putting one section in place. In the day, this tower was a little over $1 million, if I'm not mistaken. I think we financed about $1.5 million because we also had to build the building and we had to put the foundations in, and that was in addition to the steel costs. I'm guessing, I don't remember exactly. It's been 30 years since this tower went up, so it's hard for me to remember. I know the New Orleans tower was about a $5 million tower, and I know the Jacksonville tower was about $3.5 million.
I was going to say, they started to assemble that one. If you wait just a few minutes, you'll see them putting all the pieces on it.
Yeah, that's what we want to do.
That was Bill Lambert, general contractor. He had his GC license, commercial GC license in Jacksonville, Florida. Probably could have chopped a little of this video out, but as I said before, you can fast forward and get to the next section. Because the next section, you will see them putting the base section in place. Actually, I think when we get there, you'll see the base section's already in place. That's where we're going to show you how they use the gin pole and how they bring up the next section and all the sections thereafter. Now, this was a cantilever tower, which means the very top of the tower, there was a guide wires about 60, 70 feet from the very top, and then the FM antenna was mounted above that with no guide wires on that. It was held up without guide wires, the very top of the tower. And that was where we ran into the problem of having the tower a little bit too tall. But the FM antenna was totally by itself on the top, so any communications companies or TV companies that came along thereafter were going to have to be below that, which put them tower. Well, of course, nobody knew at the time that we were 49 feet too high. That sort of was a, as they say, game changer. But I continue to say throughout this video that was absolutely never the intention of us to try to pull the wool over Jacksonville's eyes. It came as big a surprise to us as it did everyone else. Later on, 6-8 months after the tower was completed, and it was determined that the tower was too high. Those are the legs of the new sections they're going to be putting together. You can see the flanges on the legs where they connect the diagonals to. As I said, it's just like a big adult erector set. Although I don't remember my erector set having any round legs to work with. Most of all of our stuff was structural steel and so forth. It was had a bunch of screw holes in it and so forth. And I did have a big number 12 AC Gilbert erector set, and I used to build lots and lots of little towers with my erector set when I was a young guy. So needless to say, it's something I've been doing for a long time. I started out building towers when I was 8 years old. Of course, they weren't anything like this. First tower that I was involved in owning was the Candelabra Tower in Hollywood, Florida. That's a 1,049-foot tower that had 2 TV stations on top of it and 1 FM station, which was Waxy, the RKO station. There's another video that we'll see eventually on that tower project. When this 80-90 rule came down from the FCC, we had a problem getting the FM stations up high enough, and so we had to have a special antenna design to be mounted on the candelabra, but not on top of the candelabra because all the prongs were used up there. It had to be on the structural part of the candelabra tower above the tower part, but below where the candelabra prongs were, and these were big panel antennas that mounted around there. So it was a very interesting way to design an antenna. The Allen Dick Company in England designed that antenna. He also designed the antenna for our Jacksonville station and our, I believe, for the New Orleans station, for a number of stations. Another interesting thing about this antenna, the Allen Dick antenna at the Jacksonville station, was there are two stations on here that, well, there were 3 stations on here that used the tower. 2 of them, the tower was, the antenna was essentially a non-directional antenna, but 1 station that was in that antenna had to be directional, and yet it had to come from the same antenna. Now, the Allen Dick Company was capable of doing that, but it created a big problem with the FCC, because they said an antenna cannot be non-directional and directional at the same time. So the only way we could get around that was to give the antenna 2 different serial numbers and model numbers, all be it the same antenna. So the directional station had its own serial number and its own number of manufacturer's number, and the non-directional had its own. But in fact, it was the same antenna. And you can imagine what kind of a problem that was once we found out that the tower was also 49 feet too high. That threw all those calculations off as well. So it was a bit of a domino effect to get it straightened out, but ultimately we were able to do so, and all is well that ends well. So without bragging about it, the stations that are on this tower are in fact 49 feet higher than any of the other stations in Jacksonville. But I didn't say that to brag, that's just a fact. It was never designed, as I said, like that. I did another edit of a video just like this, and I took quite a bit of this video out. I'm sorry about that, but like I say, it's very easy for you to fast forward here to the next phase, and the next phase is where they're actually working on the tower, the vertical part of the tower. It should be coming up here any minute. Some of the diagonals that go on the tower. Every one of them is marked, and all of the diagrams that they work off of have to correspond. So it's an erector set with paint by the numbers. So you put everything where the numbers say it should go. This tower did not have an elevator in it, so there was the climbing ladder. Look back in the back there, you're going to see in just a minute, you're going to see some of the guy wires. It was back to the left, and this guy here is sitting on top of one of the sections that they're putting together. These are all iron workers. It came from the Iron Workers Union in Jacksonville. Very specialized job. You'll notice that when they get up on the tower, they're pretty fearless. And yet, some of these guys might have come from LeBlanc up in Canada as well. Here you go. Here are the check the. This is what goes under the guy anchor. This is the guide wire. Look how big those wires are. They're not wires, they're cables. All those cables are custom made to the specifications of the tower manufacturer. As you can see, there's quite a few rolls of cable there that are going to go up to hold the tower up. And the tower's been up now for 30 years as of the time that this video was made. This video is being made on the last day of January in 2018. So it's almost 30, over 30 years. And it's withstood a number of hurricanes and had no issues whatsoever with it. It's all stainless steel, galvanized steel. Doesn't require a great deal of maintenance. They go up and grease the guy wires once a year. And occasionally they have to do a little touch-up work with the galvanizing. But other than that, they require not so much maintenance. By putting the antenna, cantilevering the antenna on the top of the tower, eliminates the need to put insulators in the guide wires. Here are some more of the, here's a truck that delivered some of the legs of the tower. They have a big bin in Oakville that they galvanize, at the galvanizing plant where they galvanize these things. After they're fabricated and built, then they just put them in this hot galvanizing solution, dip them down and pick them up and let it dry. That presumably is one of the septic tanks that was located there, I imagine. Okay, here we go. So this is the tower. And this is the about 50, 60 foot section that they're going to raise up. The transmission line is going to go inside those things on the left-hand side, those round cylindrical things. And the transmission line to the antenna, as I recall, was a 6-inch line to be able to handle the power that was going up there. And I think each station was putting something like 20,000 watts, 25,000 watts into the antenna. So it had to be able to carry at least 75 to 100 kW of power. Now, if you look here, you'll see on the right-hand side is the existing tower, and the one on the left, this is the tower that you saw laying on the ground, and on the left of that, you'll see the gin pole. And you look right there on the left-hand side of the tower is the gin pole, and I'm going to get the camera to go up a little bit higher here. And you'll notice on the top of the gin pole, come on, let's go up a little bit higher, Ron. Top of the gin pole is going to be there's a couple of the iron workers climbing up there now. And this always extends up about, if the section's 10 feet, there's a big pulley at the top of it. And so cable goes from the ground up to the pulley, then back down to the ground, and then they use a big winch to pull it up, pull the next section up, and it will get a little bit above the top of this section, and then they'll swing it around and bolt it in, and then they'll pull that gin pole up to the next section. And that's, the gin pole just creeps along all the way up the tower as they build the tower until the tower's finished, and then they take the gin pole down. Now, today, they would have put 250, 300, maybe 400 feet of this tower in place with a crane. And they would not have used a gin pole. It would go up much faster. Here you see them lifting up the next section. The tower in New Orleans, albeit it was a 12-foot face tower, it was a big, heavy-duty tower. They did set up quite a bit of that with a big crane. Now this section here weighs somewhere between 10 and 12,000 pounds.
You had your meeting the other day at Waycross?
No, I'm going up there this morning. As soon as I finish here, I thought I'd stop by here and get a little action at the tower site. And then run up there. So I need to be up there between 1:30 and 2. How long does it take to drive up there?
What I said last time, hour and a half, 2 hours.
Yeah, I figure I'll leave 2 hours. Like,
2 hours should be if you drive it.
I'll leave here.
We were talking about building a tower up at Waycross, Georgia, which is just a little bit north of Jacksonville, because there were some stations up there at trying to think of the name of that little town just north of Jacksonville, the first town north of Jacksonville that wanted to get its signal down into Jacksonville, and the tower at Waycross was midway between that little town and Jacksonville, and we were going to put up a 1,700-foot tower there. However, that never materialized. Sounded like a good idea, but some of these projects were excellent ideas, but these move-in stations, people would prefer to spend a lot more money and have a station that was licensed to or very close to the city of license that they were trying to serve. And it wasn't until a couple of years later that they got involved with the move-ins that were a stretch to make work, and yet some of them became exceptionally successful. So here we go with this next section, this next 10-foot section. Yes, I now that I remember it, we had very few iron workers local. Most of the people who worked on this tower project did come from Canada, from Oakville, Ontario. They were very professional workers. A lot of times you get a bunch of local iron workers and they go out and get really drunk after they finish the day's work, and then they can't work the next day. And these guys were exceptionally professional until the tower was topped off. Once the tower was topped off, then they had a great big beer party. And yet they had one crew that, to the best of my knowledge, none of the guys drank. So as It's one of the things we had to say a lot about LeBlanc and Royal, LeBlanc and Dick. They were exceptionally professional, really didn't have the stereotypical iron worker, tower crew reputation that a lot of the local, say local meaning the United States tower crews had. And as I recall, this was like the third or fourth tower that LeBlanc built in the United States. And then we went on to build additional towers with them in Jacksonville and New Orleans and Tampa, St. Petersburg, North Palm Beach. And once again, you get the general idea of what's going on here. You see it's being pulled up with the pulley up here at the very top of the tower. And it's going to get it up to a point where it's going to be a little bit higher than the actual tower is. So the gin pole always has to be about 10 feet higher than the tower as they gin it up the tower, pull it up the tower. And you'll notice the guys there are working on the tower, guiding it along inside the tower section. In the old days, back in the 50s and 60s, most of this work was done by Indians. I'm talking about American Indians. They were the most fearless people when it came to climbing. And one of the things I have to say about the Canadians, they always built really good stuff. George Mosley, not Mosley, but McCurdy built fabulous broadcast consoles. A lot of radio stations used at that time. Probably the best consoles on the market at the time in the probably 60s and 70s. Then a number of people started building really good audio consoles. Also, the beginning of Nautel, which to this day is probably the finest transmitter manufacturer in North America. If you want a transmitter that lasts for a long, long time, you don't want to have to worry about fixing it, you get that transmitter, the Nautel transmitter. It's assembled up in Maine so that they get some bragging rights to be able to say it's built in the United States, but it's really a Canadian company. But it's by far the best transmitter on the market. I've had a number of them from 50,000 watt AMs and 10,000 watt AMs, and the only problem I have with them is if anything ever does go wrong, you don't have a clue as to what to do because you have no experience working on it. Because what I had in Colorado Springs is still running. It's 23 years old, and I had to do a little work on it a number of years ago, and it took me a half a day just to figure my way around the inside of it because I had never had to do anything in it. And of course, they were very helpful. Their technicians got on the phone with me and guided me through it. Once I gave up my quest to do it without asking how to do it, like us guys don't like to ask directions. Well, it's the same thing with transmitters. I can fix this. I don't need any help. And sure enough, at the end of the day, I did need their help. And once I got them on the phone, it took me 15 minutes to solve a problem that I'd been working on half a day. So if there's anything wrong with their transmitters, the problem is that they're not hard to work on and they have good service, but you really need to ask. You seldom ever have to deal with it, and that's a good thing, and that's what owners want. And they cost more money. They cost somewhat more money. They're not the best, not the cheapest transmitter in town for sure. But they also today have all the special features that have USB sticks in case the audio goes off. They have remote control built in, and great remote control. You can see and do a whole lot of things on those transmitters by remote control, internet remote control that's right in the transmitter. So sounds like I'm a salesman for Nautel. I'm not, but I recommend them to anybody who will listen because it's the only transmitter I would have. All of the radio stations that we had with our company when the Hoods and I were working together on our 5 stations in Colorado, all the transmitters we had or the new transmitters we bought were Nautels. All the transmitters in Indianapolis are Nautels. So I'm a strong believer in Nautel transmitters. Okay, so here we are. Now you're going to get a look at what these guys are doing. I'm going to take another shot here of that pulley up at the very top of the tower. This was a little difficult to build because there is another tower that's located about 10 to 15 feet away from this tower. You see the guide wires there that are going over to the other tower. Now here they are putting it into place. They're going to swing it around. And as soon as they get it into place, then they just take one of their big bolts and stick it down through and get it into one of the holes is going to start getting it, helping it to line up. And once they get one leg lined up and they get the second leg lined up, then the third one is just going to fall right into place. And they can usually set a section like this and bolt it in within 45 minutes. But if you call it an hour and say they'll do, in an 8-hour a day, they'll do 6 sections. That's, if these are 10-foot sections, that's 60 feet. They try to do 100 feet a day if they can.
What do you think that weighs? What do you think that weighs?
That section,
Yeah.
I can tell you in a few minutes. In other words, there's 1, 2, 3, 4, 5. At 5, 60, that'd be 10,000 pounds.
How many sections are there on the top?
It'd be more than that. It'd be a little bit more than that. It weighs about 12,000 pounds. Because in other words, there's about 12,000 pounds per section.
And how many sections are there?
There's 5 of them. That was the 6th one.
So this is the 6th 10-foot section that they put on the tower. There they go. Pretty well lined up now. Now bring it down a little bit. Put the bolts in it. Repeat the process for the rest of the sections to get that thing up to where it needs to be. Now a couple of sections.
It's the best section to show go into place because they start getting further away.
Yeah. So you timed that one just right this morning.
Strictly by accident.
Pretty good accident.
Good weather too.
Just humid. About 3 o'clock, it'll thunder and lightning and rain. Has every day so far.
You'll notice over here on the right-hand side,
A light rain.
you'll see the other tower.
How far are those two towers apart?
12 foot, a little over, just a fraction over 12 foot between them.
So that was another little challenge about building on this property because that other tower was immediately adjacent to it and it had to go there because we needed the space for the guy anchors.
Okay, that's
Most obviously, there was no other place to put it, and we couldn't take that tower down.
Sure.
All right, I'm gonna talk loud.
Okay, good.
There is supposed to be 22 inches from the top of the concrete to the center of the tent. There is 17 inches instead of 22, which makes this big plate sit on top of this concrete, which this concrete has got to be broken out to where this is set and floats free on its own.
Okay, Bill.
In case you didn't hear that, it's that is supposed to be floating. That big piece of metal there is supposed to be floating, and obviously it's sitting on the top of the concrete.
Now we still have the same problem here with the guy anchor, with the guy
Correct.
wire.
We still have the same problem here with the guy anchor being too short, plus this guy anchor base is of 1 foot 6 inches too low.
Okay, so we're looking, I've got the camera focused now on the hairpin on the top. You want to point that out?
Okay, where the problem is they've got it fastened up there now, but it actually belongs right here. This hairpin here, out here, belongs at this point. It cannot fasten at this point because the cables are not long enough because of the anchor being the 1 foot 10 too far back.
Okay.
They have got it temporarily fastened at this point now where they can keep working.
As I said, every job always has a little hitch now and again. Some are bigger hitches than others. I've actually been on jobs where we had to stop it because there was some misunderstanding about what our permit said we could do.
The elevation of this pin is approximately 1 foot and 6 inches too low. This pin should be up higher, which is making the 1 foot 6 inches higher. That makes this piece of concrete and this all be off on its elevation point.
All right, now that business where the hairpins connect into that big piece of metal there, explain how that's supposed to float and what the purpose of it is.
This big piece of metal has to float sitting on this pin. It cannot touch anything at the bottom. It has to float because if the tower has to move in a windstorm, this plate will physically have to float. It cannot be found at the bottom.
Good. Which direction am I looking at?
This is the north side of the building.
But we're looking towards?
You're looking south. You're standing due north, looking due south.
Yeah, the camera's looking right now at two towers. It's the old tower and the new tower together. So probably kind of even tough to see. But let's pan around here to the right. And look, we're looking from the north to the south end of the north end of the building, looking south, right?
Right.
And the little doors on the left are the communications rooms.
Correct.
And
Next big door is your FM station here on the job site, which is Rock 105.
And there's where we're going to add the
Canopy.
overhang, and we're going to add that all the way along that building.
All the way down to the end of the building. Cover over the next door, which is WIVY door going into their communication.
A couple of little additions we had to put in.
This point, from this top of this sill to the top of this concrete, we're going to add a ramp where the owner of the people in the building can get in, put their equipment in, this doorway, that way. Also includes the other doorways.
Okay, we're going to do the same thing over here.
Correct? We're doing the same thing to this door, which is base concrete come from the top of this sill to the top of this concrete. Front to stick out about this much past the door where people can't fall off of it. You'll also have dirt and grass up to it where it can be landscaped.
Now, for some reason, we managed to do it over here.
Well, that was in the beginning. It was because those two little doors. Plus the overhang was done there.
Yeah, for some reason we did it right there.
So what we did is we had to add an overhang into the outside of the building because didn't want people to get rained on when they came in there to work.
We're going to come to this opening and put another set of jambs and doors in that will look just like that in this particular opening where we can secure these two restrooms.
And okay, we got the restrooms there on the right-hand side.
Right, restrooms are on the right-hand side. We're going to put up a nice folding board here with all the lights and everything on the left-hand wall. Ready to do. And we'll have nice lighting up here that will shine down on it before you can reach.
I understand the reason they didn't do it this way in the beginning is they wanted to keep the restrooms available to the people in the communications room around here on the side, but not let them get into the main building.
Right.
But the way we're going to do it now, we're further securing the restrooms. People on the outside will still be able to get into the bulletin board area, but not be able to get past that into the combiner room. We're going to put security lighting out here on the...
Yes, sir. We got security lighting over these boxes up at the top. These areas form on every building. There are secure lights all the way across every building. Also, we are going to put a canopy on this, over this door. The window approximately here, come out approximately 4 foot to keep the water and rain off the door and blowing in.
Okay, now, we're going to put grass down here.
Yes, sir. This will all be grassed. This whole area out here will have grass, and I'll make some flower beds and flowers to cover up the two. This will have some flowers and what have you around these to cover up the septic tank areas.
Now, the reason we're going to put grass out here instead of concrete is because
Everybody's supposed to go and come there.
it's supposed to enter from the
Sides.
cargo doors.
Right. Plus, there is no parking here, and there is parking on your two sides.
Right, this is just our pretty front.
Right.
Okay, for the record, we're where, Bill?
We're on the south side of the building, looking due north. These are the other this end of the building.
Explain about why the walls look funny.
The reason the walls look funny is because this is called a block filler, and the block filler was applied about an hour after it had rained, and then it came another rain about 3 hours after it was put on, and it washed it off. And that's where it ran off the building.
What's going to happen with these? Let's take a look at these. Right over there, the
Okay. These pipes, each pipe represents one JEA meter, which goes to each one of the rooms inside the building. There will be a package here about this height, all 7 meters on a board at this point.
okay.
These pipes represent going back and going into the building. These 7 pipes come up inside where you can pick up and come from this transformer here, which all these 7 here represent those 7 bays.
So the main transformer is going to be set there.
This is the main transformer from JEA. These are the pipes coming from the Hogan Road to supply us with power.
The end of this tape, we got to try to explain to somebody what happened to Larry Penner.
He told Peter to shut up and he didn't, and he kicked him.
And I was the one who said in my memo on June the 15th that the credit goes to Larry Penner and to William Lambert for a great.
And there is the combiner, the Allen and Dick combiner, built in England for 3 radio stations to combine 3 radio stations into one antenna. And that antenna is both a directional and a non-directional FM antenna. And what you see here is the completed building with the grass and everything in there. And I'm going to eventually add a little bit more. Here is the transfer switches for the 3 radio stations that connect to the generator. And here is again the Allen and Dick combiner for the 3 stations into the common antenna on the very top of the tower.